Here's our question. Can you graph y equals tan x over the restricted domain? We walk through tangent. I am going to go back and put my 3 points. Ultimately, we have 5, but not really. So I have a 0, 0.
Yes.
Okay. I have, what's this point?
Pi over and 1.
Pi over 4, 1. Technically, at pi over 2, we're at infinity.
Yes.
So that's kind of a point, but not really. What's back here, this point?
Pi over 4,
Negative 1. So I'm still looking at my 3 points to reflect across what line? What line do we reflect it across? Y equals x. Alright, so next page, can you graph y equals inverse tangent of x? Another way to say inverse, in your box they write it both ways. They could say y equals arc tan. The inverse of tangent. Okay? There's just multiple ways to write it. You can have an arc sine, an arc cosine, just for the inverse of those functions.
Yes.
Okay? And then I need you to state the domain and range. So if you've got it graphed, the original function, you should be able to take those 3 points and graph the x and the y switch. It's going to hit what? So what are your 3 points?
1 pi over 4.
So we have 1 and pi over 4.
0, 0. Negative pi over 4.
Maybe negative 1 pi over negative pi over 4.
No, that's what I said.
Okay. Maybe I just started. Okay. Now, which way do we need to go? What were our other 2 points that we didn't really talk about? Those asymptotes.
Pi over 2.
So at pi over 2,
So do you need
Is
to
it- do I need to draw a dash line?
Yeah.
Do I still need the asymptote? So instead of my asymptotes being up and down vertical, they're going to be horizontal. It will still be at the same point. Going this way. Okay? Now, as you are approaching an infinity, Brian, what are we going to do? Are we going to start?
Low,
You start.
and then
Low.
low.
But are we going to go
and
like up to it like
no,
this?
No.
No. We're going to go this way. And this one's going to go this way. Oh, yeah.
Oh, that's what I mean.
Okay. What is the domain? What is the range? Are we done? I've kind of drawn it there. Is that okay? Can you put anything in your x values? Yes. What question? Yes.
So can you use what is it called? What do you call these things like pi over 4? What's the word for them again?
I use quarter periods.
No, like just the name for like pi over 4, pi over 2, general term.
Radians.
Radians, yes. Can you use them as like an engineer if you're trying to build something? Because you know, since we're using the circle, can you use them as kind of calculate like an angle?
You can. I don't know that they actually do. The reason they did radians is so that kind of did away with units. You don't have degrees or anything. I don't know why they did it, but they did. So they wouldn't have units. They could just say 5. It would be 5 radians.
So,
We take several and do a pi over 2 for 90 degrees.
so where can you use them? Like if not the like factors, civil engineer.
Maybe. Your own, I don't know. They do lots of circles and stuff on boats, navigation,
Oh,
things like that. We'll get into some navigation. We talked about barriers before.
I-
Six radians.
Yeah.
Skirt turn.
6 radians
Wait,
would
onto
be
the
really
wheel.
far.
Got it.
Miss Evans,
Yes.
you said like a certain form of engineering beyond the sea or
Me?
yes.
No.
Just so
No.
no, oh yeah, you said insurance, right?
Yeah. We're gonna finish this because we need to get on. Okay.
I'm trying to lead into something.
Okay. What are you trying to lead into?
So if I did could I be
Spend it.
Not necessarily radians. That's why I try to talk in both. Okay. For calculus, a lot of things are going to be taught to you in radians next year. But ultimately, they go back and forth so much. You'll do a problem in radians, you'll do a problem in degrees. It's just can you process which one you need? Okay. Just to get you to think through things. All right. So what is the range of my inverse? Go ahead, Emily.
Y and there's an E,
Mm-hmm.
number, and negative
So
y
that.
pi over 2 less than y less than pi over 2.
Yes. All right. We have a few more minutes. One last thing with arc, sine, arc, cosine, arc, tangent. Graphs are very important. You're going to be asked to do those. But can you tell me y equals cosine negative 4 pi over 2 over 2? Okay, square root of 2 over 2. I would love for you to think through this problem. This is asking you what value, what degree, what radian, we're going to start in degrees, what cosine, what angle is going to give me cosine to equal pi over square root of 2 over 2. Get me thinking about pi. So cosine of what angle? Ultimately, if we took this and we went backwards, this would really say cosine y equals square root of 2 over 2.
You're just finding out what it goes.
You are literally finding out what is the angle. Cosine of what angle is going to give me square root of 2 over 2.
45.
Now,
Yeah.
absolutely 45. Okay, so I'm thinking in my brain, opposite over hypotenuse is square root of 2 over 2. Okay? And I might even draw a triangle.
I thought adjacent.
Sorry, it is. I'm thinking sine. I'm sorry.
With a 45 or 45.
Yeah. So I want adjacent over hypotenuse. And then I really don't like to do it this way. So I might unrationalize it.
Yeah, it's 45.
It has to be 45. Because if you're going to do the Pythagorean theorem, can we do Pythagorean theorem?
Yes.
I would hope so, maybe. X squared plus the square root of 2 squared equals 2 squared. That's a 4, that's a 2. Plus, you're subtracting, so x squared equals 2. What does x equal? Square root of 2. So we have a square root of 2, square root of 2, and 2. So what type of triangle is this?
45.
45, 45, 90.
9.
So what is the answer? Y equals?
45 degrees.
Y equals 45 degrees.
That's it?
What?
Doesn't it work the inverse?
These two equations are the exact same.
Oh, okay.
These two equations are interchangeable every day.
So
If you are given a triangle, yes, it's okay. It's stormy outside.
do you want us to graph it?
No.
We don't need to graph it.
At the point, x equals, really it's 2, or x equals square root of 2 over 2, y will be 45 degrees. So if we went back and looked at your graph, it's just asking for one point on the graph. Okay? What if I asked you y equals arc sine 1. You're thinking in your head, what angle, what degrees
90.
is going to give me when sine is 1? What angle is going to give me sine of that angle equals 1? I'm thinking sine of what angle? 90 degrees. Well, at this moment, I didn't specify. How many do I want? Do I need to tell you where y is in the first quadrant? Do I need to specify? I haven't. They never actually don't. They just want one answer. How many answers could you have? An infinite amount of answers because you keep going around your circle. So I'm thinking y equals inverse sine of 1. You know what's kind of funny? You can plug that in your calculator. If you're in degree mode, you'll get a degree answer out. You need to be in degrees if you're going to do it.
So you don't graph this one?
That's one answer. Y equals what? 90 degrees. Okay, so that is what? The sine of 90 equals 1. Okay? We can add 360 degrees to it and get it again. Alright? You add 360 degrees more and get it again. Alright, I think we're done. I think we're out at 15. Yeah.